We're going to solve the equation 16 to the x power plus 4 to the x plus 1 power minus 3 equals 0. The key to solving this type of equation is recognizing that the equation is what's called quadratic in form. To help you see that the equation is quadratic in form, I'm going to rewrite 16 as 4 squared. So I have 4 squared to the x power plus, now 4 to the x plus 1 power can be written as 4 to the x power times 4 to the first power. The reason being is because when you have the same base and you're multiplying, you add the exponents. So 4 to the x times 4 to the first is the same as 4 to the x plus 1. Then minus 3 equals 0. Now what I'm going to do is use the fact that when you have an exponent raised to an exponent, you multiply the exponents. So this is equivalent to 4 raised to the 2x power, which means it could be written as 4 to the x all squared. Because again, these are implying that we multiply the exponents, so 2 times x is the same as x times 2. I'm also going to take this 4 and bring it out in front. So I have 4 times 4 to the x power minus 3 equals 0. Now perhaps you can see that this is quadratic in form, where it could be written in the form u squared plus 4 times u minus 3 equals 0, where u is 4 to the x power. If that's the case, then we could solve this equation for u and then put 4 to the x back in to solve for x. So solving this equation for u gives me, well, let's think about that for a sec. If I evaluate b squared minus 4ac here, what's going to happen? I get 4 squared minus 4 times 1 times negative 3 is 16 plus 12, or 28. So the discriminant is positive, but it's not a perfect square, which means that this can only be solved using the quadratic formula or completing the square. I'll pick the quadratic formula. So we're going to have that u equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a, where a is 1, so I don't even need that. So simplifying this just a little bit, I get negative 4 plus or minus the square root of 28 over 2. Square root of 28 is 2 root 7, so I end up with negative 2 plus or minus the square root of 7. But that gives me u. I want to know x. So I go back and remember that u equals 4 to the x power. I currently have that u equals negative 2 minus the square root of 7, or u equals negative 2 plus the square root of 7. U is 4 to the x power, so I have 4 to the x equals negative 2 minus the square root of 7. Here I have 4 to the x equals negative 2 plus the square root of 7. Well, remember the range of the exponential function y equals 4 to the x is going to be the set of all positive real numbers. So we're having that 4 to the x equals a negative quantity. That can't happen, and therefore there is no solution to this particular equation. To find out the answer here, we just rewrite this as the equivalent logarithmic expression, and we would get that x equals log base 4 of negative 2 plus the square root of 7. So that is our only answer. The solution set is log base 4 of negative 2 plus the square root of 7.
now that we've solved this problem algebraically, let's solve it using a graphing utility on our Smartboard interactive whiteboard. We want to solve the equation 16 to the x plus 4 to the x plus 1 minus 3 is equal to 0. We'll go to our graphing utility. We'll go into our y equal to screen so that we can enter the equation. If we take a look back at our equation, notice that we have this expression on the left is equal to 0. That kind of lends us to want to use our 0 option on our calc menu. So back in our calculator, we're going to enter the left side of our equation in y1. We're going to enter 16 raised to the x power plus 4. Now here we need to raise 4 to the x plus first power, so we need to group that power in parentheses. So we'll open parentheses, x plus 1, and then close the parentheses. Then we have minus 3, and we will go ahead and graph that. And we're looking for where the graph crosses the x-axis. That's where the value of the left side will equal 0. You can see that that point is somewhere around here close to the y-axis. We do have kind of a lot of white space. To get a better view, we could kind of trim down our window and just look in this area around here. So we'll go to our window settings and maybe adjust from minus 3 to 3 for x, and then minus 3 to 3 for y. That'll give us a little better picture. We are looking for where the graph crosses the x-axis. That is where the value of this is equal to 0. We go to our calc menu. We pick option number 2 for 0. And we get our usual questions. We get the left bound. So that's the value for x that's clearly to the left of the point we're interested in. So we can use -1. Then we get right bound. We want to be clearly to the right. You can see that 0 is clearly to the right. So we'll use 0 as our right bound. And for our guess, we want to be close to that value where it crosses the x-axis. So we'll scroll. So we get close to that and hit enter. And we'll drag that over. So from our graphing utility, we can see that the graph crosses the x-axis at approximately -0.315. So the solution of our equation is x is approximately -0.315.